Welcome to Maths with Bob. Today we're looking at this topic called absolute value. Involves quite a lot of different things, graphs, equations and inequations. But the first thing we want to do is have a quick look at what does it mean, or what are the symbols for absolute value, and what in the world does taking the absolute value of something mean. Okay, well let's just start off with, how about we have, wow, boy, those funny strokes on the end are the absolute value symbols. Okay, they basically indicate that I'm going to take the absolute value of something. Okay, so what are the absolute value? They're long, strokey lines. So let's actually have a quick look. This symbol here, okay, although it looks very colourful, it's supposed to be a straight line. And there's another one over here. Okay. If they're on the end of something, it just means whatever's inside the something, we've got to actually make positive, or we've got to take the absolute value of that something. Now, how do I take the absolute value of something? And what does it mean? Well, I always think of the absolute value as like magnitude. You know, if you have velocity, you can be travelling in a positive or negative direction with your velocity, but your speed is your absolute value, or if you like, the magnitude of your velocity. So sometimes I think of absolute value as like the magnitude, just basically not worrying about the sign. But if something is positive already, then obviously I don't have to worry about it. Like the absolute value of, say, for instance, 5 is 5, okay? But the trouble is, what happens if the something is negative? How am I going to if you like, make the something which is negative positive, or if you like, take its absolute value? Well, if you think about it for a little while, you probably realize that it's pretty easy. All you have to do is take the negative of a negative to make it positive. Therefore, if something is negative, then we need to basically find the negative of it. Now, I need to write this fairly formally, okay, so we're going to have a look at some more of a formal definition of this. Well, okay, here we have our first problem. The absolute value of 2x minus 5 equals 7. So just have a quick look. Okay, these are the absolute value symbols here, this one and this one. Okay, that means we're going to take the absolute value of what's inside, which is the 2x minus 5, and it has to equal 7. So basically I've got to find some numbers x, which when I multiply them by 2 and subtract 5, and I take the absolute value, I get 7. Now I'm going to suggest we always solve absolute value problems using the graphical approach. Okay, and there is an algebraic approach, but it makes much more sense to me if I actually see a picture and if I draw a graph of the situation. Okay, so what I'm going to suggest is we first of all draw, let's have a look. An axis, obviously, oops. Straighten this up a little bit. Okay. So let's try and interpret what's happening graphically. Okay, so if I think of 2x minus 5, and I think of the graph of y equals 2x minus 5, what would that look like? Well, hopefully we know that if I was trying to draw like the graph of, say, y equals 2x minus 5, then the minus 5 that's the y-intercept. And this 2 at the front here, that's the gradient, right? Okay, and that would actually be a straight line. So let's actually try and draw that straight line, y equals 2x minus 5. Well, we know it would go through minus 5. Okay, minus 5 down here. Let's just say this is actually minus 5 down here. Okay, on the y-axis, let's put in some axes. Okay, so this would be the y-axis, this is the x-axis. Okay. Now, where would it go through on the x-axis? Or if you like, the x-intercept. What would be the x-intercept of y equals 2x minus 5? Okay, well, let's have a look. Okay, y equals 2x minus 5. Make y 0. Oops. Okay, 0 equals 2x minus 5. Okay, I make, what x is equal to, 5 over 2, so it's about 2.5. Okay, so let's have a look. Let's mark 2.5. Okay, so where's 2.5? Okay, so 2.5's, that's 5, so maybe 2.5's roughly here. Let's actually just a bit of a guess here, say 2.5. Now, the line would normally, let's have a quick look. Okay, the line would normally come down, obviously, through these 2 points. Okay, that would be the line y equals 2x minus 5. But the absolute value basically says that we can't actually have anything negative. Okay, so in terms of the y value, because as you know, y equals 2x minus 5, so the y value has to be reflected up. So we need to reflect this line up. So I'm going to basically just quickly shorten it, move it up a bit here. Then we're going to have to reflect it up. Okay, so I'm going to have to reflect it basically up. Now, okay, so it's going to be reflected up. So it's going to hit, if you like, the x-axis and bounce. Okay, and all absolute values are V-shape, the graphs themselves, and they will bounce. Is the angle in here 90 degrees? No. It would be if the slopes were 1 and it reflected off again, so it came in at 45 and went out at 45. The angle in the centre would be 90 degrees. But in this case, it's not, okay? You can see here they have slopes of 2. Now, where is this value here? Okay, this value here obviously would be 5 because it's been reflected up. Okay, now, here we have a graph of y equals the absolute value of 2x minus 5. That's what the graph would look like. It's a V shape. It's bouncing off the x-axis, i.e. it doesn't go negative, at about 2.5, the x-intercept. Now, okay, let's actually draw in y equals 7 now. Y equals 7. Okay, let's have a look. 7, okay, let's just do it roughly here. Okay, this would be the graph of, say, y equals 7. And, as you know, it would go through 7 on the y-axis. Okay, now there are a couple of things. The first thing, when I look at one of these graphs, I always think, well, okay, which arm is the positive arm? Well, this is the positive arm. I always call this the positive arm. And this one over here would be the negative arm. Okay, this one here would be the negative arm, and this would be the positive arm of that absolute value. Now, the positive and negative arm can be written as, if I write here, I could actually write this as, the positive arm is just 2x minus 5. Okay, and that would be the y equals 2x minus 5. That would be the bit of that graph going up that way. Now, if I actually reflect it, the negative arm would have an equation, y is equal to, okay, the negative of 2x minus 5. Okay, and sometimes I actually just write that as, just instead of the y there, I just write that as negative 2x minus 5. And sometimes I don't even worry about writing the arm. I just look at the graph and say, okay, well, the positive is 2x minus 5, that's a positive part, and the negative part is the negative of 2x minus 5, so it's minus 2x minus 5. Okay, so what is this question basically saying? Okay, I'll just move this down a bit because I need to find these intersection points. The graph is just saying, okay, where is that graph equal to 7? Well, you can see, okay, this point here and this point here. These will be the solution points to that, what's called absolute value equation, okay. And what we're after is actually their x values. So this value here and this value here. Now, we don't know them at the moment, but there's an easy way to interpret this, and that is quite easily. But let's have a look. Well, we know the positive arm 2x minus 5 will intersect the y, so let's have a look at where the positive. Let's look at the positive, okay, arm, which would be 2x minus 5 is equal to 7. Okay, 2x is equal to, you can see here, 12, and x is equal to 6. Okay, so one of the solutions would be 6. So let's mark that in. This is the solution here, 6. Okay, so one of the solutions would be 6. Okay, what about the other solution? Okay, so let's have a look at the negative arm, and that would be the minus, or the negative of 2x minus 5, and that's equal to 7 again. You get, what, negative 2x plus 5 is equal to 7. minus 2x equals 2 and x equals negative 1. Okay, so this value here would be negative 1. Okay, so they are the two solutions. Now, a very important point in absolute value is actually, and especially equations, is to check whether your answers actually do satisfy the equation. So let's just put in 6. Okay, 2 6s are 12, minus 5 is 7. Is the absolute value of 7 equal to 7? Yes. Okay, so that one works. Okay, how about negative 1? 2 times negative 1, okay, that's negative 2. Minus 5 is negative 7. Does the absolute value of negative 7 equal 7? Yes, that's from the definition. So, okay, all right, fantastic. Okay, so the solutions are, okay, solutions x equals negative 1 and 6 would be the solutions to that absolute value equation. And you can see here it's been done graphically. Okay, what happens if now I change this to what's called an absolute value inequation or inequality? I have the absolute value of 2x minus 5 is less than or equal to 7. Now, to interpret this graphically, it basically says where is that absolute value graph less than or equal to 7? So it's where is it, if you like, below 7? You might like to think of it like that. Where is that graph below 7? Well, if you have a look, obviously it's below 7 over here. This is where you can see there. It's obviously below 7 in this section here. And how would I actually write a solution to that? Well, you can see here, this is one of the points here, one here, and there's obviously another point here, next value here, which are important in that solution. So how would I write the solution? Well, I could just write that as, if you like, the solution. Okay, writing it in set notation, okay, is the set of x such that x now it's less than or equal to 7, so it's going to be between minus 1 and 6. Okay, so that would be the solution to that absolute value inequation, right? So you need to draw the graph. You need to actually find the points of intersection of the y equals 7 and the positive and negative arms to get the negative 1 and 6 as before, and then you just interpret the actual inequation as where is the graph below 7. Okay. Okay, you can see here I've now just changed the direction of the inequality symbol and made it a greater than. Now, how am I going to interpret this? The absolute value of 2x minus 5 is greater than 7. Well, I always like to think of it, okay, the absolute value graph is actually bigger than 7. Well, where is that occurring? Well, let's just have a look at the graph. So over here it's bigger, and over here it's bigger. Okay, so you can see it's above the line y equals 7 in those spots. So where does it change over from being above to below? Obviously at minus 1 and 6. So now, okay, we have to be just a little careful here because, okay, we can't include those points. So the solution now, okay, in set notation would be x such that. Now, we can, I will do this in say x is greater than 6, comma, and x is less than minus 1. I have seen some ways of writing this where you flip the inequality symbols around, but I think it's better to write it like this, that in fact it's the two parts of the number line where x is actually larger than 6. So it's, if you have a quick look here, it's over here, okay, and going out that way, those x values will give you a height above 7. If you have a look here at minus 1, okay, down here, and you go out this way, those x values below negative 1 will in fact give you a y value or a height, if you like, above 7 as well. Okay, all right, so let's actually, okay, I'm just now going to show you something which is possible with absolute value equations, and that is that there is actually no solution. At the moment, there is a solution. You can see that the y equals absolute value of x, of 2x minus 5 rather, is this is where the line 7 is still there, actually from the previous example. So if I actually grab this line and I moved it down, you can see here still some solutions. Okay, only one solution. Okay, if I actually get move that line, I just delete that little purple spot there. But if I actually delete this line, well, not delete this line, move that line below the x-axis, say to -2 or -3, then this equation, they say the absolute value of 2x minus 5 equals, say, minus 2, okay, there won't be any solutions, okay? As you can imagine, I can't take the absolute value of something and get a negative value, okay? So that would be a situation where there would be no solutions, okay? So something could be, say, a negative value. Okay, let's actually change this again. So let's select this, okay? Okay, here we go. Let's make it into another line, okay? So here we have something like, what would that be like? That would be like, okay, the absolute value of 2x minus 5 is, say, let's call it x plus 1. Okay, so there would be a solution. You can see there are actually two solutions, okay? In that case, there will be two solutions. You can see the solutions here and here will be the two solutions. Now, it is also possible to actually move this line down. Okay, suppose I grab this line and I move it down here. Okay, then there are no solutions to the absolute value equation 2x minus 5 equals that line. Now, what would that look like? Well, that would look like something like the absolute value of 2x minus 5. Try and get this pen to work. 5, okay, is equal to, say, what would that line say be? Let's do it x minus 2, okay. Absolute value, say 2x minus 5 equals x minus 2. Okay, so that would have no solutions. And you can see that this idea of checking your solutions in absolute value equations is very, very important. Okay, and obviously, if this was an absolute value inequation, okay, here we now have the absolute value of 2x minus 5 is less than something with no solutions. You can see here, where is that graph less than that line? Well, there's nowhere it's less than that line. Let's actually make it have some solutions, okay? Let's actually make it have some solutions. Okay, let's move it up. Here we go. There, it would have some solutions now because the graph actually is below that line for, you can see here some values. These would be the values here, this value here, and this value here. Okay, those two values there would be, okay, the boundaries, and we'd have to actually drop them down to the x-axis, down to here, and then where is it less? Well, it's obviously in this section, in between here and here. If I draw the circles on it, it turns into the circles here. Okay. All right, okay. So you can see that it's quite important when you are doing absolute value equations and inequations that, in fact, you are looking out for solutions, things where, in fact, there are solutions and there are no solutions. Okay. Now, obviously, I could turn this into a line as well, drop it down. So, again, let's just move this up a bit. Can't see it now. Okay. So here again, there are no solutions. Where is that the absolute value of 2x minus 5 less than that line, say y equals minus 2? Well, in fact, it's never less than that value, obviously. Let's make it have some solutions. Obviously, as before, there are some solutions now. Okay, there's one solution here, and there's no solutions there. Okay, we'll just leave it here for the time being. We'll look at some more complicated examples later on. Thank you for watching.